Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. And students, today we are going to do viral mock test for your board exams. Okay, so let us start this without wasting any time. Okay, so are you all ready for this? Everybody, let me know in the comment section so that we can start with this paper. Okay, and I want all of you to solve this along with me. It's not like okay, ma'am is solving, we will just watch the ma'am solving this, right? You have to solve this along with me, right? Okay, yes. Now let us start the session. The first question, guys, and the PDF of this will be provided to you in the description box, right? The first question on your screen is, first question is the order of reactivity of following alcohols with halogen acids is. Halogen acids, that means HOX they are talking about, the reactivity order you have to tell, right? Okay, yes everybody. So reactivity order A, B, C is given to you, right? With halogen acid. Now firstly you need to tell me that which thing will be formed here. So if you see, for haloalkanes are prepared from alcohols and halogen acids, right? Okay, haloalkanes like RX or these are prepared from this, where hydroxyl group of alcohol is replaced. Basically if you have ROH, hydroxyl group is replaced by the halogen over here, right? Okay, now options. Now basically they are telling you about which thing will be present here, which is more stable, more reactive than this. Wait, just let me tell you the order here, right? So basically when you convert ROX to RX here, ROH to RX, so what you need to see here, that the order of reactivity here is going to be 3 degree, then 2 degree, then 1 degree, right? Okay, because if you say that this is forming a carbocation is formed here, reactivity will be 3 degree, then 2 degree, then 1 degree. Now, out of here you need to see which is 3 degree, which is 2 degree, and which is 1 degree. Can you tell me that? Out of this, you have to tell me which is 3 degree, which is 2 degree, which is 1 degree. So if we talk about this is 1 degree. Here OH is connected to that carbon which is connected to 2. So it is 2 degree. OH is connected to that carbon which is further connected to 3 other carbons. So this is 3 degree. So clearly we can say C is maximum stable, then B, then A. Because 3 degree, then 2 degree, then 1 degree. So answer is going to be C, D, A is the correct answer. Okay? Understood? Chal. Next question on your screen, guys, we have DNA fingerprinting means DNA fingerprinting, right? It means sequencing of nucleotides in DNA, sequencing the bases present in the double helix like C, T, A, G, all these bases, sequencing that. Information regarding unique sequence of bases on DNA for a person, information regarding the unique imprints of fingerprint of a person. So basically DNA fingerprint, whenever you take fingerprint, what you say, right? Information regarding the unique sequence of bases on DNA. In biometric also, what we do, and what are these, why we take our thumb on that particular uh, thing, whatever they, in the biometrics, right? That means our fingerprints will be scanned, right? Okay, so fingerprints are going to be different here. So that's why information regarding unique sequence of bases on the DNA of a person, right? So answer is a sequence of a base on DNA is unique for a person, and information regarding this is called DNA fingerprinting. It is same for every cell and cannot be altered by any known treatment. Okay, understood? So that's why it is something that in CID also you must have seen that actually this is used, right? Okay, next is 1 mole of organic compound A. There is 1 mole of organic compound A with the formula C3HA2 reacts completely with 2 moles of HI. 1 mole of organic compound you have, right? That is C3HA reacts with 2 moles of HI to form X and Y. When X is boiled with aqueous alkali form Z. Z answers the iodoform test. Now, beta, iodoform test means either it can be CH3, C double bond O, something like that, or it can be CH3, C, this is H, this is OH over here. Either it can be something like this, right? Now, this can be your Z, right? They are saying there is one O here, so both of them can be the answer. The compound A, they are asking what is the other hint? 1 mole of organic compound with the formula this react completely with 2 moles of HI. 2 moles of HI. 2 moles of HI. So that means here what you will have 1 mole of organic compounds. This organic compound is reacting completely with 2 moles of HI to form X and Y. Right? X and Y, that means what will happen? What will basically happen? There is some, this should be ether only. Okay? So if you have ROR, right? If it reacts with HI, right? What will happen? It will give you ROH and it will give you RI. Okay? These two things it will give you. Right? When Y is boiled with aqueous alkali, it will aqueous alkali. Y, any of this can be Y. It is boiled with aqueous alkali. Aqueous alkali, that means NaOH. It will form any of these two compounds. So basically, this is methoxyethane, this is propane-2-one, ethoxyethane and propane-1-one. So the choice is between one alcohol and one ether. So that can be one of the ethers here. Why? Because of these reactions. Because of these reactions. Now, what you have to see that one of the answers should have one CH3 group on the terminal, and even in alcohol one CH3 group on the terminal. That is possible if you have methoxyethane. I'll tell you how. It's ether reacts with HI to form alcohols and alkyl halide. Alcohol on oxidation gives iodoform test. So basically, let us take this example CH3O C2H5. Okay. Now, what will happen? Let's say you have the formation of CH3OH and this is CH3 CH2 and this is I. That is formed here. Now, after that, they are saying the alcohol on oxidation. If this alcohol, if you oxidize this, that means this will be CH3, or you can also say this can be this can be HCHO. Wait a minute. CHO on oxidation. Then that should be alcohol on oxidation gives. So this will not be the alcohol. The alcohol would be this one. है ना? Alcohol would be this one, right? So it will be CH3I, right? And this will be CH3 CH2OH, right? After this, on oxidation, it will form CH3 C double bond OH, right? Okay. Now this will give positive iodoform test. This will give positive iodoform test. Understood? Right? In case of, we have two ethers here, right? In case of ethyl ether, it is not possible, right? Because in ethyl ether, what will have? You want to have the formation of that particular answer which will give you the iodoform test, right? Okay. So answer will be methyl ether here. Methoxyethane here, right? So answer is A is the correct answer, right? Okay. Next is, moreover, they are saying 1 mole, na? So that's why, right? Okay. Chalo. Next is the common name for pentane dioic acid, right? So this is basically pentane dioic acid. You have 5 carbons, right? And you have 2 COH, right? Okay. So answer will be, correct answer will be glutaric acid. So it is pentadioic acid is known as glutaric acid. This question has also been asked in JEE mains, right? Not the same question, but question related to ascorbic acid, right? So 2, it is, that is why it is called oxalic acid. Butane dioic acid is known as succinic acid. Any of this can be asked. Hexane dioic acid is called adipic acid. Heptane dioic acid is called pimelic acid. Okay, so all these are very, very important for you and they are directly mentioned in your NCERT table, right? Okay, they are directly mentioned in your NCERT. That's why this becomes very, very important for you. Next is, if 75% of first order reaction was completed in 32 minutes, 75% of this has been completed. Mostly they will ask you question on first order reaction, only 32 minutes it is. 50% of the reaction was completed in which? They're asking you the T half here. So if you find the value of K from here, right, then put this in this particular value, that T half is equals to 0.693 divided by K. You will get your answer in that, right? So you'll solve it regarding that. Now, if you see the formula first order reaction, that is K is equals to 2.303 by T log. Now I told you one thing, that whenever things are given in percentage, always take initial as 100, right? So 175% is consumed or left. They are saying 75% of the reaction is completed. That means it has been consumed. So that means out of this, subtract 75, it will be 25 here, right? That means it is going to be 4, right? Directly you can tell the answer here. Time is given to you. Time is given to you, that is 32 minutes. And this is also in minutes, so you don't need to convert it to anything else, right? So it will be 2.303 divided by 32. This is log 2, and here it will be 2, right? Why? Because 2 raised to power 2 it will be, na? Because it will be log 2 raised to power 2. Then 2 will come in the front. It will be 2.303 divided by 32 multiplied by 2 divided, and this is log 2. Right? Log 2 is 0.301. Right? So directly put the values, get your answer. This is your K. After that, put this in T half. Okay? So this is the value. Here they have solved in a different method. I'll tell you, solve it this way. Right? Why? Because otherwise, na, you will get confused here. In the board exam, you don't have ki, okay, there is less time for me. In competitive exam, we do such thing, right? But in board exams, you have enough time, right? Okay. So now this is, after this, T half is going to be 0.693 divided by the K that you have calculated here. Put this value here and you will get your answer to be 16 minutes. So answer is going to be C is the correct answer. Okay. Next question is, match the items of column 1 with appropriate entries of column 2, right? Column 1, you have to match it with column 2, right? So here it is, very simple, guys. So as you can see here, I is what? I is a Van Hoff factor, right? Okay. Achha, what is Kb? Kb is ratio of observed molar mass to actual molar mass. So I will be this thing, right? This will be Kf, this will be Kb, and this will be the mole fraction of the solute, right? Okay, so answer, this is from the solution chapter from colligative properties, right? So answer is A2, you can see over here. B is what? 1, so answer is going to be A is the correct answer. Okay, chalo. Next question is carbon tetrachloride. Now, this is from dipole moment, chemical, not chemical bonding. Basically, this is a general question, right? On the basis of dipole moment, carbon tetrachloride has a dipole moment of which? Right? Dipole moment, guys, you have to tell. Right? Carbon tetrachloride is CCl4. It is in the tetrahedral geometry C. This is Cl, this is Cl, this is Cl, this is Cl. So basically, can I say that, okay, chalo, let me just show you the structure, even if, because here na students get confused. So that's why I'm just going to show you the full structure here, how we are saying that the dipole moment is going to be 0, right? No cramming, nothing over here, guys. I don't believe in cramming, right? Okay. So just give me a second. By the time, let me know in the comment section how many questions you are able to solve till now, right? Is there any problem in any question that you're facing, right? Are you able to solve the questions? Are you feeling confident? And how much syllabus you have already done, right? Okay. Have you watched the marathon? And have you watched the naming reactions video? Have you watched the full naming reaction, distinguished test, important organic chemistry conversion, all these important lectures, right? So guys, this is your tetrahedral thing. So basically what will happen, this particular thing will form a you can say a resultant that you have studied in vectors. So there will be one resultant for this one that will be over here. This one and this one will cancel each other, The above and the below will cancel each other. And in the end, what you will have, dipole moment is going to be 0, right? Okay, dipole moment is going to be 0. Next is, among the following, the which bivalent ion of the first transition series shows maximum magnetic moment? Maximum number of unpaired electrons you need to have, right? So just remember this thing, beta. This is very important for 12th inorganic chemistry. Very important. Saktiv kar man fi ko ni ku jan. Okay. So over here, what you will see, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Right? Okay. And 30. Right? Okay. Chalo. Now, what you will see, cobalt is at 27. That is 4s2 3d7. Right? This nickel is at 28. 4s2 3d8. 2, 8, 2, 8. Then manganese 25. 4s2 3d5. Right? Then you have iron 26. 4s2 3d6. Now, I'm just writing down the exceptional electronic configuration here also. 4s1 3d5 is for chromium, and for copper it is 4s1 3d10. Okay, so these are exceptionals, right? Now guys, what you will see here, after losing electrons, every one of them are losing 2 electrons. So 2 electrons lost here, right? You'll be left with 5. Here you will have 5 unpaired electron. Here you will have 4 unpaired electron, 3 unpaired electron, and 2 unpaired electron. How? Because 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's how 2 unpaired electron, right? Okay? Now, maximum unpaired electron you can see in 5, that is in manganese. So answer is going to be C. Maximum, first transition shows maximum magnetic moment. And if you want to calculate the magnetic moment, you can directly write here 5.9, 4.9, right? This is, let's say, 3.8. This is 2.7. Ma'am, in subjective, है ना, direct trick will not work. You also have to write the formula, right? Acha, this is so optional, na? This is some MCQ. But still, if they ask you n plus 2 Bohr magneton, that is the formula for your magnetic moment. Okay, is that clear to everybody or not? That is clear, right? Okay, next is everybody. Next question. Let us see how many of you are able to answer this. The slope of line in a plot of concentration versus time indicate. They are saying the slope of the line in the plot of concentration versus time indicate this, beta. From the options, we can see that they are talking about first order reaction, right? So it will be K is equals to, or you can say T is in the this, na, T is equals to 2.303 divided by K log of A naught by A, right? Okay, A is the final concentration, right? You can also write it as AT, right? Now, they are saying the plot between, the slope of line in the plot of concentration versus this. Okay, concentration versus time you have to check here, right? So what we will do here, we'll do very simple thing here, right? This will be Tk divided by 2.303. This is log of A naught minus log of AT, right? If we compare this, this will be y, x versus y, na? So time is y. Y is equals to, slope is this, na? Y is equals to mx plus c. This will be the intercept, right? Mx plus c. Mx plus c, if we connect it here, This is positive, this is negative. So answer should be K by 2.303. Wait a minute. Slope of line indicates minus K while intercept is R naught. Wait a minute. What? The slope of the line in the plot of concentration versus time. Mm, because here though it is coming out to be K by 2.303. So I think they should have mentioned here whether it's a first order reaction or a second order reaction, right? In that ways only we can answer this, right? The slope of the line in the plot of concentration versus time. Slope of the line in the plot of concentration versus time. Simply they are saying. Acha, ठीक है. If you simply say that you have a graph, right? Okay, they are saying that this is between concentration and this is the time. Okay, and if we take it as a negative slope, then it is going to be like this. The intercept is this. Okay, so this is what they are saying, that the slope will be minus k. That is possible, right? Okay, but they should have mentioned here that whether it's a first order, second order, what kind of reaction. So I'll just eliminate this question over here, right? Because what I'll tell you, the crux of this, basically you're going to compare it with y is equals to mx plus c, right? This is your slope always and always. This is x-axis, this is intercept, and this is y-axis, right? So if they are saying A versus T, so X versus Y, right? From that you can easily pick out the slope and the concentration over here, right? Okay. Graph based questions now, they will ask you on different things, right? Okay. Also on Arrhenius equation, different cases they can ask you that, right? Next is how to do the following conversion, right? This is the conversion, RCOOCl to RCHO. Now, this is one of a very important naming reaction, right? RCOOCl get converted to RCHO. How to do the conversion, guys? Very simple. What you need to do here? H2PD. This also here it should be RCOCl. Okay, RCOCl. This is Rosenmund reduction, right? Okay, Rosenmund reduction, and here you are going to use the Lindlar's catalyst, right? Lindlar's catalyst. Okay, so directly basis of naming reactions, directly they can ask you with this particular thing, right? Okay. Next question is, give IUPAC naming of the following compound given below. Acha, IUPAC naming, very simple. They have given you particular compound. We know that this is OH, so it will start from 1, 2, 3, 4, 5, 6. On fifth position, there should be chloro, hexane, and 2-ol. So answer is going to be B is the correct answer, right? Okay. And don't ignore IUPAC naming because very simple questions can be asked here. The correct increasing order of basic strength of the following compounds, right? So basic strength, we know that this question is from amines, that is directly proportional to electron donating group, inversely to electron withdrawing group, right? This is donating group, it is donating, it is withdrawing. So it is directly proportional to the electron donating group. That means third is going to have the maximum basicity they are asking. Now, third is going to have maximum basicity, which is there in this particular D option. Then you will have first, because it is having no effect. Here you have electron withdrawing group. Why so? Because when you're taking electrons from the nitrogen, what is a base which can donate the electrons? You're taking electrons from this nitrogen, that means you are decreasing the basic strength here. So it is going to be minimum. So answer is going to be D is the correct answer, right? Okay. Next is some assertion reasoning questions, right? Here it is. Cellulose is not digested by human beings. Cellulose is a polymer of beta D glucose, right? Okay. So correct explanation they can also directly ask you statement 1 is correct, second is correct on basis of these, right? So here basically both the statement are true, but they are not the explanation of each other, right? Okay. Understood? So both the statements, as you can see, cellulose is not digested by human beings. Cellulose is a polymer of beta D glucose, right? It is a polymer, you can say it is a polysaccharide of that, right? Okay, and it is not digested by human beings, right? Okay. Next is benzaldehyde is less reactive than ethanol towards nucleophilic addition reactions. Benzaldehyde is basically this thing, right? Nucleophilic addition reaction means what? When a nucleophile is getting added here. Nucleophile means something which is attracted towards a positive thing, right? Itself it is negative. Ethanol is more sterically hindered, right? Ethanol is this. This is ethanol. Tell me, students, which of the following is correct? Everybody. So, beta, as you can see, assertion is correct, but the reason is the wrong statement here. Reason being, as you can see, ethanol is more sterically hindered. I have just drawn this in front of you. Can you see? This is so small, this is so big. Right? Definitely, it is not the correct answer. This benzaldehyde is less reactive. Can you tell me the reason behind that? Why this is less reactive? Because if you see this here, C double bond O, this is H, exactly what is happening here. This is connected to, benzene is connected to that atom which is further connected to a double bond. So what will happen? It will take out electrons from, it will show minus M effect. Minus M effect means on this carbon, you will see more negative charge. So nucleophile will not be attracted. Nucleophile will be like, I want positive charge. You have more negative charge, right? Okay, right? So this benzene is going to donate the electron to this carbon. This is also going to donate it, but mesomeric effect is more dominating as compared to inductive. So this is the correct statement. But I'm telling you the reason here because maybe in your exam, final exam, they can ask you the reason that I have told and mention it over here. Then that would be, then it would be A is the correct answer, right? Okay. Next is, okay, hydrolysis of 2-bromooctane. Now they are saying hydrolysis of 2-bromooctane proceeds with inversion of configuration. Okay, 2-bromooctane, right? Inversion is there in which? Inversion is there in SN2 reaction or SN1 reaction. See, SN1 reaction is a two-step reaction. It is carbocation formation. So, racemization will be there. SN2 is one-step reaction. In one-step reaction, you have transition state where definitely there will be Walden inversion, right? So you just have to see whether it's SN1 or SN2. That is the question that they are asking you, right? Okay. Next is this reaction proceeds to formation of carbocation to give a positive octane. Positive means the configuration has been inverted. Octane to ol as the product. In SN2 reaction of optically active halides are accompanied by inversion of configuration, right? Okay, okay. This reaction, wait a minute, two reasons they have given. This reaction proceeds to the formation of carbocation to give opposite, okay, as a product. In SN2 reaction, the optically active halides are accompanied by inversion of configuration. So firstly, so you have to see hydrolysis of 2-bromooctane, right? Octane is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 2-bromo means over here you have bromine. Now, is it like very sterically hindered? No, right? So it can definitely go through SN2 mechanism over here, right? So what we can say that assertion is true that it is going through SN2 mechanism. That is why it is getting inversion product. But reason is false. Can you tell me the reason? This statement is correct. This statement is correct, but this statement is not correct, right? Yes, you are right that in SN2 reaction, optically active halides are accompanied by inversion of configuration. But this carbocation formation is a SN2. Wait a minute. No, even this is not correct. Both are not correct. Both are not correct. Because here it is, why I have written here SN2? It should be SN1. Wait a minute, wait a minute. SN transition state, it should pass through SN2 mechanism only. Yes, 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 right. Wait a minute. Then in the second reason, this statement will be correct. This statement will be incorrect. That is why overall reason will become false. Why? Because this is not correct. Reason proceed through formation of carbocation. Carbocation formation is a SN1 mechanism, right? So that's why this is going through SN2 mechanism, right? Okay, so that becomes false, right? Chalo. Next question is the oxygen. Now they are saying the oxygen of OH group in alcohol is attached to sp3 hybridized carbon, right? Oxygen in OH, oxygen of OH group in alcohol is attached to sp3 hybridized carbon. Okay, the bond angle of alcohols is 109 degree 28 minutes, right? This is carbon, this is oxygen, this is H. It has two O over here, right? Okay, but it also has carbon over here. This is sp3, right? Okay, this is sp3 hybridized. Because this carbon is also sp3 hybridized, this oxygen is also sp3 hybridized, but it will create some kind of angle deflection here. So oxygen in OH group in alcohol is attached to sp3 hybridized. That is the correct statement. But if you talk about the reason, that will be false. Why? Because carbon is also this carbon, this oxygen, this carbon is also, it is having tetrahedral shape. This also is having tetrahedral, right? Like this kind of formation. So what will happen? The bond angle of these two will change. Bond angle of this in alcohol is slightly less than tetrahedral. It is due to the repulsion between unshared electron pair of oxygens, right? Okay, that is why it is slightly going to drift, right? Okay. Okay, now moving towards the subjective questions here, right? Okay, let us do subjective questions. Using the valence bond approach, deduce the shape and magnetic behavior of this ion, right? This ion you have to deduce the magnetic behavior and shape. So as you can see, okay, let us see this. This is chromium, right? NH3, right? 6, and this is 3 positive. So I'm firstly to always calculate, but I am telling you the steps here, okay? This is from VBT, very, very important. For sure, question will be asked from here. This is x plus 0 equals to plus 3. So answer is going to be plus 3. Oxidation state is plus 3, right? Chromium, we know that here it is 4s2 3d5 because it has atomic number 25. Chromium 3 positive is what? It is 3d4. Now you have to see ammonia is a strong field ligand or a weak field ligand because it is octahedral. So either it can be sp3d2 or it will be d2sp3. Okay? Or either it will be d2sp3. So what you can observe here that there is definitely, wait a minute. Arey? Karman, wait a minute, have I written it wrong? Huh. Saktiv Kar is 24. Wait a minute, this is 24, na? It will be 4s1. Yeah, I told you, na, exceptional electronic configuration of chromium. 3 electrons it will take, it will become 3d3, right? So now what you will observe here, that NH3, right? That NH3, what will happen? NH3 sometimes it behaves as strong field ligand, sometimes as weak field ligand, right? But here it is behaving as a weak field ligand, right? Okay, so here what will happen? There will be no pairing of electrons and you will be left with d2sp3, okay? So it is a inner octahedral complex with unpaired electron 3, so magnetic moment is going to be 3.9. Hybridization is octahedral shape. The complex is paramagnetic because it has unpaired electrons due to the presence of unpaired electrons here, right? Okay. Next is, why is chromium 2 positive reducing and Mn3 positive oxidizing when both D4 configuration? Why chromium 2 positive is reducing? Very, very interesting question, right? Why this is reducing? Why this is reducing? Why manganese is oxidizing, right? This is from DNF block. These kind of questions are frequently asked from DNF block, right? So here basically chromium 2 positive. We just have to focus on the electronic configurations here, okay? So I'll also draw the electronic configuration, right? Theory part I have written here already, but the diagrams and all I'll draw it for you, right? Okay. So chromium first you need to write it is 4s1 3d5. Manganese we know that it is 4s2 3d5, right? Chromium 2 positive, है ना? They are talking about chromium 2 positive here. It is 4s nothing but it will be 3d4. It is reducing means it is going to decrease the oxidation of something other. Itself it is going to oxidize. That means itself it is going to increase the oxidation number, right? Okay, it is going to increase the oxidation number. Can you tell me why? That means you can say itself it is going to lose the electron. Is reducing as its configuration changes from D4 to D3. Now, ma'am, why D3 is more stable? Why D3 is more stable? Because if you talk about this thing here, 1, 2, 3 electrons, it has a symmetry. In CFT, we draw T2G, EG. Then it will have symmetry over here. The latter having half-filled T2G orbital, right? So that is why this is T2G, this is EG because it is stable. That's why this wants to lose one electron and itself get oxidized and reduce something other, right? Okay. Let us talk about this level, that is manganese. Now, if you talk about manganese over here, manganese is oxidizing, manganese 3 positive. Manganese 3 positive is 3d4. Now, why it wants to accept one electron is that it results in D5 configuration, 3d5 configuration, right, which is more stable for manganese, and hence this is oxidizing, it is reducing in nature, right? Okay. Next question is, answer the following. So what is the question here? For a chemical reaction, what is the effect of catalyst on the reaction? From chemical kinetics, this question is. But firstly, one thing should click in your head is from which chapter it is, from which topic it is, so that you can answer that completely. All the, when we say that, okay, this is from chemical kinetics, full chart of chemical kinetics is in my head, right? Why is the probability of reaction with molecularity higher than 3? Then wait a minute, why is the probability of reaction with molecularity higher than 3? Very rare. Okay, so very simple questions both are. Catalyst increases the rate of reaction by providing alternate path with less activation energy. If initially activation energy, let's say it is this. If initially, let's say activation energy is this one, right? After adding the catalyst, activation energy will be this one, okay? Activation energy will decrease here. Understood? Activation energy will decrease here. I know, guys, the screen is little bit, I think, shaking. So I don't know why that is happening. So I'm so sorry about it, right? Okay, next is as the number increases. Now, next is why molecularity more than 3. That means if you have 3 molecules that are colliding with each other, reaction will not occur. Because of steric hindrance, right? Okay, probability factor. The chance of simultaneous collision decreases. That means probability of more than 3 molecules colliding simultaneously is nearly impossible, right? The possibility of molecularity being 3 is also very, very low. More than 3 is so not only possible, right? Okay. Next question is, why do gases always tend to be less soluble in liquids as the temperature is raised? Okay, everybody, from solution chapters, these two questions are, they have given you choice here. Firstly, though, let me know, if you were at my place, what you would have solved. Calculate the freezing point of solution. See, if you're good in calculation, choose this. Okay? It should be like a matter of just few seconds. It's about the selection, what you're choosing. Why do gases always tend to, if you're confident, see, I'll tell you one thing. If you're actually confident, I'll tell you a very simple trick. Okay, very important thing. That is a very important tip for your exams, for your board exams. If I would have been at your place, I would have chosen this. Can you tell me the reason? I'll always prefer a numerical question over a theoretical based question. I'll always prefer a reaction over a theoretical question or a reasoning question. Because in reasoning questions, still they can deduct marks if your reason is not that much elaborated, right? What we can't say what kind of teacher will check your answer sheet. But numerical, everyone will have same formula, right? Okay, you will have the same calculation, same answer you will write. Reason will also be same also, but the way you represent the reason, if you're very confident that my presentation skills are very nice, I can write a full detail with proper diagram, everything, then go for that, right? Because this will consume less time, this will be less time, this will take slightly more time, right? Okay, so the choice also matters here, right? Considering you know both the questions, because when you know both the questions, then there is choice. Oh my god, I know both. Then some students, what they do, they end up solving both the questions. Such a stupid thing to do in the exam. They have given you, they will not give you extra marks for that, beta. They will not give you any extra marks for that, right? In the exam, I know that feeling. Oh my god, I know this also, I know this also, I'll answer both of them. you'll you'll end up wasting your time that you could have given to some question that you don't know, that will give you maybe more marks, right? Okay. Why do gases always tend to be less soluble in liquids as the temperature raise? So gases and liquids, right? Okay, gases and liquids. If you talk about gases and liquids, let's say carbon dioxide gas and liquid, right? So as you increase the temperature, what will happen? So beta, when you increase the temperature, na, molecules will go here and there. So what will happen? The solubility is going to decrease here. Solubility is going to decrease when you increase the temperature, because molecule of gas are basically incompressible. That is why they will move here and there, right? Okay, so properly you can answer this. Mostly dissolution of gases and liquid is a exothermic process. It is because of the fact that this process involves decrease in entropy, right? Basically entropy means what? Randomness, hai na? So this process involves decrease in entropy. Thus increase in temperature tends to push the equilibrium towards backward direction. As a result, solubility of the gas decreases, right? Okay, you can also mention this with the help of one statement that Ksp is inversely proportional to temperature, right? That is why solubility decreases. So different reasons you can give which are directed towards this thing only, right? Okay, if I were a teacher, I would have given marks to that student. That if I were a teacher means if I were a teacher who is checking your sheet, right? Because when I used to check the sheets of students, what I used to do, it's not, I was not a very strict teacher while checking the sheets, right? But there are strict teachers as well. Understand one thing, in the for the examiner, they get just very less time to check the answer sheet. So for them, the more you present that, okay, this is the statement, these kind of things, if you write in your exam, that will really help the examiner. है ना? कि okay, this person has directly given it, right? And I have also made a video on the presentation skills, how to impress the examiner. Go and watch that. That is really going to increase your number by maybe 10 to 15 marks easily, right? Okay. Next question is, calculate the freezing point of the solution containing 0.520 gram glucose dissolved in 80.2 gram of water. Okay. Now, beta, freezing point they are asking you of the solution containing this much of glucose, that is your W2, right? This can give you M2, right? Dissolved in this much of water, this will give you W1. Water is M1 will also be there. Okay? You can easily calculate the value of molality from here. Kf is given to you, right? You have to calculate the value of delta Tf over here. So just put this formula, that you can just directly put this over here, that delta Tf is equals to Kf because it is glucose, so water factor is 1, right? Molality is what? It is W2 by M2 multiplied by W1 multiplied by 1000 over here, right? This is delta TF, right? Okay, this is delta TF, right? Okay, so KF is already given to you, W2 is also given to you in the question. M2, you can calculate the value of glucose, that is molar mass is 180, right? W1 is also given to you, 1000 is given, we know, right? So from that, put the values, you can just put these values and you will get the answer to be 0.0669. Okay, rest is the calculation part. In exam, if you feel that you have very less time, for example, in the exam you're like, oh my god, I have just 5 minutes left, I have 3 questions to answer, and you're at this question, right? What to do now? Now stop solving it, directly put all these values. Till here you can do this, you don't have to do. If the examiner is nice, they will not cut your marks, right? If the examiner is strict, they can cut maybe 0.5 marks from that, right? Try to solve it fully, but if you have no time in the end, then at least put the values, put the formula that you know, right? At least they will give you some marks, right? Okay. Draw the structures of following compounds. 4-chloropentane 2-one, 3-bromo-4-phenyl pentanoic acid. Right? Okay. Now, basically, you just have to draw the structures here. 4-chloropentane 2-one. So, this is pentane. 2-one means double bond over here. 1, 2, 3, 4. 4 is chloro. Right? Next is 3-bromo-4-phenyl pentanoic acid. Firstly, draw pentanoic acid. That is 1, 2, 3, 4. And this is, let's say, pentanoic now, 1, 2, 3, 4, 5. Okay, now they are saying 4-phenyl, that means over here on the 4th position you have phenyl, on the 3rd position 1, 2, 3, 3rd position you have bromo, right? And this is your COH group, that is OIC group, right? Okay, so directly you can write that. Next is calculate the potential of hydrogen electrode. What they're saying, calculate the potential of hydrogen electrode in contact with solution whose pH is 10, right? Whose pH is given to be 10, guys. pH is given to be 10. Everybody here. pH is given to be 10. Anybody in the comment section? So, potential of hydrogen electrode, pH is given to you. From there, you can calculate the value of H positive concentration, right? From there, you can calculate the value of SHE from the Nernst equation. Very, very simple question here. Now, beta, if you write down the formula, the reaction here, it will be H positive plus 2 electrons give rise to half of H2, right? Applying Nernst equation, E cell is equals to E naught cell minus 0.059 divided by N factor log of what is product? Product side you have, you can also write it like this, okay? You can also write it like this. Pressure of, I'll just write it here. E is equals to E naught cell minus 0.059, right, divided by N log of pH2 divided by H positive, right? So, pressure of hydrogen gas is given to be 1, right? So, that's why we directly take it as H positive over here. Concentration of H positive, if pH is 1, beta, very simple, very simple. If pH is given to be X, then H positive is going to be 10 raised to power minus X. If pH is given to be 10, then H positive is going to be 10 raised to power minus 10. Okay, so answer is going to be 10 raised to power minus 10 over here. So you can put the value here as 1 divided by 10 raised to power minus 10. Right? Okay. Now, after this, what you have to do, you just need to solve the value here. This will come to this side, it will be 10 raised to power plus 10, 10. Log of 10 is 1 only, so it will be 10. So after multiplying, beta, this you should not write here, right? Okay, so basically what you have to do, this will be 10 raised to power 10 only, right? Now, if you move it here, it will be 10 of log of 10. Log of 10 is nothing but 1, right? So, you just need to multiply it over here. What is N factor, ma'am? Number of electron gained and lost. That is 1. So, N factor is going to be 1. E naught value, beta, for hydrogen, it is 0, right? So, this is going to be the answer. That is minus 0.591, right? Okay. Chalo. Next question is, Next question is the rate constant for first order reaction, right? The rate constant for the first order reaction is 60 per second. How much time will it take to reduce the concentration of reactant to 1 by 10th of the initial value? So in fraction they have given us, right? Okay. Rate constant is given to you. Time they are asking you, it is 2.303 divided by k is what? 10 raised to, it is 60, na? So it is 60, right? Log of, initially if they have given in fraction, I'll take the initial value as 1. If in percentage, I'll take the initial value as 100. If in fraction, I'll take initial value as 1, right? So they are saying how much time will it take to reduce the concentration to this? That means we are not taking something out. This is the reduced value, that is 1 by 10th. So it will be 1 by 10 over here. It is going to be 2.303 divided by 60. This is log 10, that is 1. So it is 2.303 divided by 60, right? That is going to be the answer over here, right? That is going to be the answer over here. Understood? Chal. So by that you can directly answer this. Next question is, give equations. Let's solve this, guys. Let's solve this, guys. Give equations of the following reactions, right? Okay, of the following reactions. First is oxidation of propane 1-ol with alkaline KMNO4, bromine with CS2, dilute HNO3 with phenol, treating phenol with chloroform in presence of this. So let us solve all these reactions directly. These are direct reactions, okay? First is phenol with Br2 in CS2. Between CS2, it is going to give two products. One is ortho, one is para. In water, it is going to give tri-substituted ortho and para product, right? Ortho will be minor, para will be major always, unless and until there is any hydrogen bonding, right? Now phenol with dilute HNO3, with dilute it is going to give you two different products. One is ortho, one is para. But in this case, because of the hydrogen bonding over here, this is going to be the major product. But beta, with concentrated, it is going to give you tri-substituted ortho para products, right? Acha, with phenol with CHCl3 plus aqueous NaOH, that is nothing but this is which reaction? CHCl3 plus aqueous NaOH. This is Reamer-Teamer reaction, guys. Reamer-Teamer reaction. Reamer-Teamer reaction, you have the formation of salicylic aldehyde. In Reamer-Teamer reaction, if you use CCl4, that will give you salicylic acid. That is, instead of the CHO, you will have COH here, right? Okay. Next is, acha, 4 only we had, na? Dilute this. Also, we have done this also. First one we have not done. Oxidation of propane 1-ol with alkaline KMNO4. So, acha, this I forgot, na? Propane 1-ol with alkylic. Wait a minute, this is alkaline or what? Alcoholic or what? Alkaline. With alkaline KMNO4, which is a very strong oxidizing agent. So it will directly convert alcohol to carboxylic acid. So it is going to be CH3, CH2, COOH. Right? Okay. Next question, beta. Here it is. Write the structures of major product of expected from the following reactions. Mononitration, dinitration, mononitration of this. Okay. Basically, the expected products we have to see. First is, wait a minute. What is the 3-methylphenol? Na? 3-methylphenol. Okay. First is 3-methylphenol. 3-methylphenol means over here 1, 2, 3. This is CH3. What you will have with the nitration. So, first thing is with this you will have, dekho, OH is a ortho-para directing group, right? Okay. So either this position or this position you will have, right? Okay. Either this position or this position you will have for NH2. Now, ortho-para is also over here. Okay. For this, the ortho position is this one or this one, and para is this one, right? So if you talk about the combined effect here, right? If you talk about the combined effect here, what can happen? Firstly, तो NO2 will be attached over here. ठीक है? Then it will be attached on either of the two positions. This is also ortho, this is also ortho. Now you tell me which position it will choose. Why I'm saying that this position it will not choose? Because NO2, again you have OH, CH3, all big groups. Steric hindrance will be there. That is why at this position and this position there will be NO2. So one you have NO2 over here, one you have NO2 over here. That is the correct answer. Right? Okay. Next is mononitration, because here you have used dilute HNO3. Here is dinitration of the same thing. But in dinitration, what will happen? At this position and this position, in the same product, NO2 will be attached. So here you have NO2 here you have NO2 over here, right? So NO2 is attached on both the positions. Last one is a different reactant, that is phenyl methanoate. Okay? And mononitration of phenyl methanoate. So basically you tell me what is phenyl methanoate. So firstly this is phenyl methanoate. Okay? Now bacha, as you can see, here oxygen is attached to, here benzene is attached to that particular atom which is having lone pairs, right? Okay, so it is going to show plus M effect, right? Okay, it is going to be ortho para directing, right? That is why either this position or this position. But para being the major product, you will have the para substituted product in the mononitration. Understood? Chal. Next question is an aromatic compound. Now here what you have. Everybody try to read the question and try to answer this. This is basically a question that has been asked so many times. Very important question, right? Okay. An aromatic compound A, molecular formula is C8H8O, gives positive 2,4-DNP test. Okay. So positive 2,4-DNP test means it is having carbonyl group over here. It gives yellow precipitate of B, compound B, on treatment with iodine. Okay. That means it is showing positive iodoform test. So that means if it is a aldehyde or ketone, it should be like this. Okay. B, this is positive iodoform on treatment with iodine and sodium hydroxide solution. Okay. Iodoform test is positive. You can write here. Iodoform positive. Okay. Compound A does not give tolerance test. Now we are saying this compound A does not give tolerance test. Tolerance test is given by aldehyde. That means definitely it is a ketone. Okay? That means it is a ketone. Because tolerance test and Fehling test is given by aldehydes. And tolerance is given by both aliphatic aromatic. Fehling is given by aliphatic aldehydes. Right? On drastic conditions with potassium, and we need to have 8 oxygens, 8 carbons here. On drastic conditions with potassium permanganate, it forms a carboxylic acid. Acha. C. Wait a minute. It gives yellow precipitate of compound B. Okay. Compound B means something like CH3CO, CONA, something like that will be there. CH3, C double bond O, ONA will be there. Okay, that will be compound B. On drastic conditions, potassium permanganate, it forms carboxylic acid. Okay, that means this is directly converted to carboxylic acid of formula C7H6O2. Okay, so when it is forming this carboxylic acid, it is taking out one carbon from here. It has in C, it is having 8 and this is having OK. Okay. Okay. Which is also formed along the yellow compound in the above reaction. Okay. Got it. Yellow compound that we have seen here, that also because iodoform test also give carboxylic acid. Identify A, B, C and write all the reactions. Okay. So now We have done most of the thing here. We just need to write down the particular thing here with the formula, right? This we know that it should have this kind of compound. So now completing the structural formula here, we have this acetophenone over here. Okay? Why? Because the formula is C8H8O. Benzene is C6H6. Then we are left with C2H2O, which definitely is C2H. Wait a minute, this is C6H6. Now, if you take out 6 here, if you take benzene over here, so it will be C6H5. Then it will be C2H3, C2H3O. है ना? Because when you talk about a substituted benzene, it is having 1, 2, 3, 4, 5 hydrogens. So C6H5. Then you are left with C, 1 carbon here, and 1 double bond over here. Understood? How you got a hint that this is a cyclic compound? How you got a hint of that? Because we know that this formula can only exist in when it is a cyclic compound. For a normal chain, for an open chain, this should have at least double the number of hydrogen atoms, right? Okay, so that is why this is the A compound. Now with 2,4-DNP, what will happen? 2,4-DNP beta is what? This compound will react with NH2, right? Okay, or you can say, ठीक है, NH2, this is your Z. Z I have mentioned over here. This is your Z. I'll not draw it over here again and again. So H will be eliminated, H2 will be eliminated from here, and oxygen will be eliminated. So this carbon here will be double bonded to this nitrogen, and then it will have this. And basically what will happen now? You will have this thing, NH2, and this is Z. Z is what? This is in hydrazine when you replace this hydrogen with this particular group. Okay? So show you, because this reaction is very, very important. This is H, this is benzene. 2,4-DNP means here you have NO. This is, you are having NO2. Right? Now what will happen? When this N2, this H2 will be eliminated, and this is double bondedly attached to the carbon over here, and this carbon is having CH3 and one phenyl group. Okay, so that's how you have this particular compound here, right, that I have written here, right? Chalo. Next is with I2 and NaOH, what will happen? This bond will break, and over here you will have CHI3, that is the yellow PPT, right? And you will have this carboxylic acid here, right? That is benzoic acid. After that, beta, what will happen? After that, what will happen with KNO3, which is the oxidation? I think KMNO4 they have given, right? On oxidation, simply with KMNO4, what will happen here? You will have the formation of benzoic acid, which was also, they have also given this hint that this was actually formed in iodoform test also. They have also given this hint over here. Okay, also formed yellow compound, okay, which was also formed in the iodoform test. So these kind of questions are very, very important, and they are good tricky questions for your board exams. And usually most of the students, they skip it. In panic mode, they skip it, right? Okay. Next question is, when a steady, now what we are saying, when a steady current of 2A was passed through, so basically this is from Faraday's law, electrochemistry, was passed through two electrolytic cells A and B containing electrolytes ZnSO4, CuSO4 connected in series. So that is from Faraday's second law, I can say. 2 gram of CO is deposited on cathode of cell B. How long the current flow? What mass of Zn was deposited at cathode of the cell? So both the things you have to take, Faraday first and Faraday second law, both will be applied here, right? Both will be applied here. How it will be applied? As you can see, it is having CuSO4 and ZnSO4. So in CuSO4, this is the thing that will happen, because they are saying this is reaction is taking place at cathode. So it is trying to gain the electron. ZnSO4, I'll also write it. Chalo, ZnSO4 is not that needed right now. Okay? So we'll not write it. Chalo. Directly what you can say, 1 mole of CO deposited by 2 Faraday. Okay? That has been written here. That when a steady current of 2A was passed through electrolytic cell A and B of this, right? Okay. Okay, जी. So here what you can say that basically what is happening, 1 mole of Cu is formed from 2 electrons. But directly if you want to make 1 copper, you need 2 electrons. For 1 mole of copper, you need 2 mole of electrons. That means 2 Faraday of electrons you need. So 1 mole of copper deposited by 2 Faraday charge, right? So here that means 63.5, that is the molar mass of copper is having 2 into this Faraday's 96500. That means if this much gram is having this much charge, then 2 gram of copper will have how much charge? 2 into 96500 divided by 63.5 multiplied by 2. Unitary method we have applied. This is having this 1 gram will have 63.5. 2 gram will have multiplied by 2. The same thing we have written here. That is 2 into 2, 96500 divided by 63. Right. So unitary method we have applied here. We have calculated the charge over here. Once you know the charge, okay, once you know the charge, we know formula. Q is equals to IT, current is given to you, right? Charge you have calculated, you can easily calculate the value of time here, right? They have asked time only, that how long did the current flow, right? So time we have calculated here, that this much the current will flow. Now, second they are asking is, what mass of zinc is deposited? Now here they are asking you from second law of Faraday. That is a comparison. So in this comparison, we know that the ratio of weight is equal to the equivalent weight of the two things that are connected in series, right? So weight of copper by weight of zinc is equals to equivalent weight of copper and equivalent weight of zinc. Equivalent weight of copper, because it is gaining 2 electrons, so n factor is 2, so it will be 63.5 divided by 2. For zinc, the molar mass is 65. In zinc also you have Zn, it will lose 2 electrons, so again the n factor is 2. So 2 will cancel each other, you will have this. Weight of copper in the question is given to be 2 gram, okay, where it is 2 gram of copper it is given, right? We don't know what is the value of weight of zinc, so it will be divided by zinc, right? So you can easily calculate the value of zinc here, right? And it will come out to be 2.047. Got it? Yes, students. Chalo. Beta PDF you will get, don't worry about that. If you're not able to see this, na PDF you will get, right? Okay, from the PDF also you can see. In each of the following pairs of compounds, identify the compound which will undergo SN1 reaction. SN1 means it is a two-step reaction. It is a two-step reaction. It is a carbocation formation. Carbocation formation. Which carbocation is more stable? Here halogen is connected to that carbon which is further connected to 3 carbon. So this is a better stable carbocation. Here it is very difficult to form carbocation over here because phenyl is not at all positive. Phenyl cation is not at all positive. But benzyl carbocation, that is CH2 positive, because of the resonance here, it is very stable. Right? So answer is, here it is 1, here it is this one. Right? Okay. So here it is 3 degree, here it is benzyl chloride. Okay. Next question is, determine the value of equilibrium constant. Value of equilibrium constant, beta. Determine the value of equilibrium constant Kc delta G for the following reaction. Okay? So E naught cell is given to you. Okay? With the value of E naught, you also have, firstly, so what is the n factor? Number of electron, here it is 2. Here also it is 2. So n factor is going to be 2 here. Okay? E naught value is given to you already. You just need to put the formulas here. Okay? Just put the formulas here that between delta G and E naught, delta G is equals to minus NF E naught. F value we know 96500, N is N factor is 2, right? E naught is given to be 1.05, right? So directly from here you can calculate the value of Gibbs free enthalpy, right? Okay, equilibrium constant is slightly tricky because here you will have to use antilog also. But still, if you know how to calculate perfect, if you're like having problem in that, you're like, ma'am, I don't know if I'll be able to calculate this or not. Beta, this is not a objective question. So even if you leave the question till here, they will give you full marks only. So you don't need to worry about. A very, very strict teacher will not give you that marks. But otherwise, they will not cut marks if you leave it over here also. But yes, if you're able to calculate anti-log also, they'll be impressed. Hai na? So impression means more marks, right? So delta G is equals to minus 2.33 RT log Kc. Kc you have to find out. R value you know, that is 8.314. Temperature, is it given to you? Temperature is not given to us, so I'll take the temperature as room temperature, that is 298 Kelvin, right? From that you can calculate the value of Kc directly. ठीक है जी, चलो. Now let us see beta one kind of question. These kind of question also you will see in the exam. Okay, this kind of question also you will see in the exam where they have asked you that okay, this is the paragraph, है ना? Firstly, what stupidity the students will do? Firstly, they will read out all the paragraph, है ना? Paragraph they will read out. Then you will see the questions. Then they again will read the paragraph, है ना? That is a silly mistake that students do, right? Firstly, beta, just see the questions. Okay, if you already know the questions, you don't need to see that paragraph over here. Right? If you don't need, you can select that whether there is some hint given in the paragraph or not. So first is, which of the 3D series of transition metal exhibit largest number of oxidation and why? 3D series of transition which exhibit the largest number of oxidation. So largest number of oxidation number is exhibited by manganese, that is from +2 to +7. Largest number of oxidation state it will exhibit. So you don't need to see the paragraph here, right? A transition metal exhibits higher oxidation state in oxides and fluorides. Give reason. So basically in oxides it has multiple bonds, in fluoride it is maximum electronegativity. A transition metal exhibit higher oxidation state in because oxygen and fluorine are highly electronegative elements, small in size and strongest oxidizing agent. A very good electronegative element will be oxidizing in nature. That is why they exhibit higher oxidation state over there, right? Next is, how will you account for the increasing oxidizing power of the series? Beta, this is based on the oxidation number, right? This is due to increasing stability of the lower species which they are reduced. Okay, wait a minute. Increasing stability of lower species. MnO2 na account for the increasing oxidizing. This is not stability. This is the oxidizing power. So beta, what exactly happens? Manganese has maximum oxidizing power. Then you have chromium, chromate. Then you have VO2 positive. So based on the stability and how, if you talk about, if you let's calculate the value over here, this is x minus 8 is equals to minus 1. X is equals to +7. They are in the highest oxidation state. That's why it would want to get in the lower oxidation state very easily, right? That's why when it want to get into lower oxidation state very easily, because this is in +7 oxidation state, it will get reduced and it will oxidize something else. So it is a very good oxidizing agent, right? So based on the oxidation states it is. Next is MnO is basic, whereas Mn2O7 is acidic in nature. Give reason for that. So you can directly see by the oxidation state, right? MnO, that is X is equals to +2. Mn2O7, that is 2x minus 14 equals to 0. 2x is equals to 14. X equals to 7, right? Okay, X equals to 7. So here we can say that if X is equals to 7, so simply that's why this is more stable. Higher oxidation state, oxide is acidic. When metal in lower oxidation state, it is basic. So that is why this is more acidic in nature as compared to MnO. Considering that the central metal atom should be same. Okay? Acidic strength is directly proportional to the oxidation state here. Right? Next question is regarding this particular paragraph is given to you. Again, beta, I am not going to read this full paragraph. If you can directly answer, try to answer directly. Very rarely that you will find the answer over here very rarely, right? How many questions? One, two, three, four, and that's it. Four questions more we are left with. Okay, four more questions. Chalo, everybody, try to answer this. Usually, students waste their time in reading this full paragraph. Okay, what will happen if a plant cell kept in hypertonic solution? Hypertonic means which has more osmotic pressure. So what will happen to the plant? Plant will shrink. Can you tell me why? Because from hypertonic it will try to lose water, right? Because it is having more osmotic pressure, right? So it will get shrink. If you have hypertonic, then it will swell up, right? Okay. Next is blood cells are isotonic with 0.9% of sodium chloride solution. And whenever we have some intravenous injection that are according to this 0.9% sodium chloride solution only. Blood cells are isotonic with 0.9% sodium chloride solution. What happens if we place blood cells in a solution containing 1.2? Beta more, hai na? This is a very, very important question from your NCRT. Very, very important question, right? So basically, if you have this proper concentration, body will remain intact. If you don't have this proper concentration, either it will swell up or shrink, right? So now what will happen over here? This percentage of chloride means you have more solute. More solute means what? Right? Is hypertonic with respect to this, because you can see more solute means it is having more osmotic pressure, because this is directly proportional to mole fraction of solute. That means it has more osmotic pressure. That means this particular solution is hypertonic. Hypertonic means it is going to shrink. Okay, so blood cells, when blood cells are placed in this solution, water flows out of the cells. They shrink due to loss of water by osmosis, right? Okay, next is, beta, understood na? This is osmotic pressure is directly proportional to mole fraction of solute, that is number of moles of solute. So if this concentration of solute is more, that means it is a hypertonic solution having more osmotic pressure. Okay. Next is what happens when external pressure. Now they are saying what happens when external pressure applied becomes more than osmotic pressure of the solution. External pressure that you're applying, that becomes more than the osmotic pressure of the solution. Okay. So if external pressure applied becomes more than the osmotic pressure, then reverse osmosis will occur, right? Then the solvent molecules from the solution pass through semi-permeable. Ulta will happen, opposite will happen, and it is called reverse osmosis. This process is used in RO system for the desalination of the water, right? Another or part is given for this. It is given what mechanisms help in the transportation of water in plant. What is that? Very, very important. That is called, wait a minute, in the upward direction, osmosis help in transportation in the plant. Okay? Okay, this particular hint you can see over here. Osmotic pressure of seawater is this. This is pressure must be applied in seawater. You can get a hint over here, right? Okay, but if you ask me, very rarely you will find the use of these paragraph in these questions. Okay, okay. In some questions you will find, but firstly go through the questions, then just once read the paragraph. Okay. Next is attempt any 5 of the following. You have to attempt. Okay. What are purines, pyrimidines? Okay. This and that based on biomolecules. You have these many questions. Let us answer one by one. What is purine and what is pyrimidine? Right. Pyrimidine, these are 3 bases derived from pyrimidines. That is cytosine, thymine and uracil. Right. They are present. T is present in RNA. T is present, but in RNA, U is present. In DNA, it is A and T. In RNA, it is A and U. Right? A is adenine. Purine is a adenine. Adenine is a purine. So there are 2 bases derived from purine, that are adenine and guanine. In DNA and RNA, both of them are present. Just give me a second. Okay. So here it is in DNA, purines present in DNA and adenine and guanine and pyrimidine present are cytosine, thymine. While RNA, purines are same, but pyrimidines in RNA are cytosine and uracil. The only difference is this thing. In DNA, you can also write it. It is A 2 bond with T. In RNA, you have A 2 bond with uracil. Both of them has both of them has G 3 bonds, 3 hydrogen bonds with C. Right? Okay. Next question is write the full forms of DNA, RNA, deoxyribonucleic acid and ribonucleic acid. Right. Next is name the vitamin whose deficiency causes convulsions. That is vitamin B6. Right. That will cause convulsions. Next is which vitamin B group can be restored in our body? Which is that vitamin B12 in our body, and my body is not able to restore this vitamin. From the past 2 years, my vitamin B12 is so low, so low. Huh? Because I'm a vegetarian, so that's why it's so low. Very sad. My body is not able to restore it. But definitely, why? Because external sources, you take good diet. Because mostly vitamin B12 is present in non-vegetarian diet. So for vegetarian, they need to have either very very good diet, or we definitely need to have some vitamin key tablets, है ना? So that is also which I myself don't like, but have to, right? Okay. Next is what is the difference between nucleoside and nucleotide? A very very small difference here. That in nucleoside it is having pentane or sugar combines with nitrogen base, but in tide you also have phosphate group along with these two things, along with nitrogen base and sugar you also have phosphate group, right? Next is write one difference between alpha helix and beta pleated structure. Alpha helix is beta like a spiral, beta plated is like this. Okay, so you can also draw the diagram here. Alpha helix has intramolecular hydrogen bonding, beta plated has intermolecular hydrogen bonding, right? Okay, intermolecular hydrogen bonding, right? Alpha helix result due to regular collision of polypeptide chains, while alpha plated, or you can say beta plated or polypeptide chains are stretched and arranged side by side. Okay, this is stretched and arranged side by side, right? Okay. Next is what is nucleic acid? Why two strands in DNA are not identical but are complementary, right? Why? Because of the nitrogen bases, right? Okay. Nucleic acid are polymers of nucleotides because of hydrogen bonds are formed between specific pairs A and T, A and U, G and C, right? Pairs between A and T and between G and C in case of DNA. That is the reason specific. They don't overlap with each other. That is the reason that they are not identical but they are complementary to each other, right? Now, some enzymes are named after the reaction where they are used. Okay. What name is given to the class of enzymes which catalyzes the oxidation of one substrate with simultaneous reduction of another substrate? So that enzyme very very important, oxidori, oxido reductase. Basically, beta, whenever you talk about enzyme, na, there will always be ase. Invertase, right? Invertase. Why? Because it is used in inversion of sugar. So there is no such as a big thing in that. Oxidation, oxidase, reduction is reductase, right? So they have just written, they have clubbed these two names together, right? Okay. Chalo. I think this is the last question of today, is it? Yes. Okay, second last question, 33 questions, na? Second last question this is. So basically, IUPAC names, beta, you have two questions are given. This is from coordination chemistry. First here, IUPAC name of the following coordination compounds. 6, they are asking the IUPAC name. Here they are asking you the formulas, right? So one by one, we will write everything here, right? Chalo. Firstly, let us talk about the IUPAC name. So here I'll just give you the rules here, okay? Because knowing the rules is important. Here what you will see, firstly, always if coordination sphere is positive, always central metal atom is going to have the same name. And in Roman letter, you write the oxidation state of the central metal atom. So it will be hexaamine cobalt uh, chloride. Okay. And here it will hexamine cobalt 3 chloride, because oxidation state is coming out to be 3. Here it is amine and chlorine. है ना? Chlorine, it is negative ligand. Whenever you have negative ligand, it is mentioned as ido or odo, right? So it is chlorido instead of chlorine, right? So because C is before, pehle you will have amine, na? So it will be pentamine chlorido cobalt chloride. Okay, so it is pentamine chlorido cobalt chloride. Okay, next one is very, very important. Whenever you have coordination sphere as anion, instead of the name of sentimental atom, you write it as, like you have cobalt, you will write it as cobaltate, right? Iron, you will mention it as iron only, right? Or you will mention it as ferrate, chromate. 8 will be there in the end, right? So here it will be potassium hexacyanoferrate. Okay, potassium hexacyanoferrate. Next one is, here you have C2O4. C2O4 is a oxalato. It is a negative ligand, oxalato. So it will be, and here the charge is -2. So also one thing, if here it is 3, here it will be -3. So it will be X minus, here it is 3 oxalato you have, 3 into 2, because the charge on the oxalato is -2. So it will be 6, it will be -3, X is equals to +3, right? So that's how you calculate the oxidation number, right? So here it is uh, trioxalato ferrate, potassium trioxalato ferrate, right? It will be potassium trioxalato ferrate. Okay, next one is, this is palladium, okay, and here it is chlorine. So it is tetrachlorido, potassium tetrachlorido palladium, okay, palladium. This is also done. Last one is, you have NH3, you have Cl, you have NH2CH3. Now this NH2CH3 is methylamine, right? So what you will write, firstly, this starting from A, this is from C, this is from M. So it will be diamine chlorido methylamine platinum chloride. Okay, understood? That's how you will write it. Understood? Chalo. Now beta, directly we will see how come you will answer these oxidation numbers here, how you will answer these things, right? How you will answer these things over here, how to write down the structures here. Okay. So beta, first thing is, they are saying that I'll just mention 2 to 3 over here, rest of this is your homework, right? These are your homework. Okay, these are your homework. Let us see whether you are able to answer this or not. At least you should try to do something by yourself also. Okay, this is your homework. Let us try to answer this. Hydroxozincate. 8 means zinc is in the negative coordination sphere, right? So here it will be negative. Because zinc is having, very, very important guys, because zinc is having, this is having oxidation number 2, right? And here it is hydroxo. Hydroxo is 4. Hydroxo is 4. Here you will have zinc. And they are saying that oxidation state of zinc is 2. So how you will answer this? It will be 2 minus 4 is equals to -2. That means over here it will be -2. Okay? That's how you will answer ZnOH4 2 negative. Okay? Let us take one more example. Potassium tetrachlorido palladium. 8 means this is in the negative sphere. Okay? Potassium means here you will have potassium, this is Pd. Okay? Tetrachlorido means 4 chlorido you will have over here. Okay? Tetrachlorido palladium 2. Now, bacha, see, if here you want to have 2, so it will be, it is 2, this is -4, it is -2. So here you will have -2. Here -2 means here you should have 2. So answer is this thing. So it will be K2PdCl4. Understood? K2PdCl4. Chalo. Let's do this third one. That is very, very simple, beta. This is diamine dichloridoplatinum. There is no platinumate, right? So that means here it is in the positive sphere only. This is PT. Diamine means two amines, NH3 twice. Dichlorido means Cl2, right? Now, platinum is having two oxidation state. Beta, for that, platinum 2, that means it is an ion only. There is no counter ion mentioned to you, right? So here what we will write, this should be platinum, it is 2, so it will be 2. Wait a minute. I'll just write it over here. It is 2, 2, right? And here it is plus 0 minus 2 is equals to 0. So here it will be 0. That means here you will have no charge. That's why in the answer you don't have any charge over here. Okay? Understood? In the same way you will do rest of the questions. Okay? In the same way you will do rest. Let me do just one more question over here for those students who are still confused in this. Beta see, this is potassium tetracyanonickelate. 8 means this is in the negative part. Nickel is in the negative part. Potassium means counter ion is potassium. Okay? Tetracyanonickelate. Tetracyano means CN4 you will have. Okay? Nickel is given to be 2. Oxidation state, write it here, 2. Where it is nickel is given to be 2. Minus 4, it is minus 2. So here it will be minus 2 because here it is minus 2, here it will be 2. So answer is going to be, this is the correct answer. Got it? Okay. Chal. Last question of today from organic chemistry. Let us do that, right? Let us do the last question of organic chemistry of today, right? Write the structures of main products when benzene disonium chloride react with the following. Benzene disonium chloride is a very, very important compound. All the reactions are very important for you. Okay? Now, let us do this. Benzene disonium chloride with H3PO2 and water. It is directly going to give you benzene. Even if here you have ethanol, then also it is going to give you directly benzene, right? Okay. Benzene disonium chloride with CuC and KCN, that is Sand-Meier's reaction, it is going to give you a cyano, that is you can say benzonitrile, okay? Instead of this N2Cl, you will have CN over here. Benzene disonium chloride with water, it is going to give you phenol, but the condition is that the temperature should be greater than 5 degrees Celsius, because between 0 to 5 degrees Celsius, it will be a stable compound, right? Okay, yes. Next question is, arrange the following in increasing order of their basic character. देखो बेटा, basic strength is directly proportional to the, अच्छा, this is given in the aqueous, very, very important question. In gaseous phase, it is simple, है ना? Electron donating group, right? So, more the availability of lone pair, more is the basicity, right? For 3 degree, then 2 degree, then 1 degree, because for 3 degree maximum availability of lone pairs, because of 3 plus I groups. But in aqueous solution, right? In case of methyl and ethyl, you have different answers. So when you have ethyl over here, the answer that you will get over here is, wait a minute, yes. So the stability order, I'll just give you the answer here, yes. For ethyl, the answer is going to be 1 degree, then 3 degree, then it is 2 degree. It means 2, 3, 1. Okay? But here also mention one thing, that is for methyl, it is going to be 2 degree, then 1 degree, then it is 3 degree. For ethyl, it is, if you have situation 2 degree, then 3 degree, then 1 degree. This is a very, very important thing. Reason is going to remain same for both of them. You will say that, yes, we have different factors here. One is steric factor, other is plus I effect, right? So other is hydration energy. So you will write these, the stabilization of conjugate acid. So basically this is the hydration energy, right? Hydration energy is making this 3 degree, right, more stable, right? So basically like that you will have different cases here. And after the overall basic strength, right, that will differentiate in methyl and ethyl. Three factors: steric hindrance, hydration enthalpy, and inductive effect. Right? Okay. Chalo. Next question is the relative. Acha. Next question is, what are the major product of the following reaction? So these are the three reaction major product they are asking you. Chalo. So first is C6H12, that is nitrobenzene in SnHCl. That is reduction. It will be reduced to aniline here. Right? That is NO2 to NH2. Diazonium chloride in presence of Cu2Cl2HCl, that is it will form chlorobenzene. Done. Next is CH3CONH2. Then you add Br2 case, that is Hoffman bromomide degradation reaction. This CO will be vanished and you will have the formation of CH3NH2. That is going to be the answer in the end. Okay, guys. So that was your paper for today, and I really hope so that your preparation is going really well, because I have covered everything on this channel regarding boards. Now what you have to do is just go and download the PDF over here, and within 5 to 10 minutes go and just revise this full session, right, for more clarity, the questions that you were finding tough. And guys, one more thing, that for all the students who are preparing for JEE Advanced, right? So we have a very good book for you, that is Rank Accelerator book for really good questions of JEE Advanced. Trust me, the questions are really good, right? I have also taken a session on that. Your mind will boom, like after watching those kind of questions, after solving those questions, you will get the level of confidence for JEE Advanced. Right? Okay, so that is available, physics, chemistry, math. The link is in the description. Go and check that out. And guys, if you want this book for totally free of cost, then you can get enrolled to Eclavia batch. Then we are going to not, I wouldn't say push you, we are going to pull you from JEE mains to JEE advanced level, right? Even in the classes, this book will be discussed, right? Okay, the questions of this book will be discussed, right? So the link is in the description. The batch is going to be entirely in English. Okay, now for those students who are preparing for JEE means attempt 2, for you guys, we have now, beta, here so you can see, ma'am, there is board also, but now we have launched also one batch that is just for JEE means 2, right? Okay, so the link is in the description. You can go and click on that link, right, just for JEE means 2. If you want a batch for JEE means 2 plus BITEEE, that is also available to you, right? Link for all the batches are in the description, right? You can go and check that out, and let me know in the comment section if you like this session, and if you want a session on last minute revision, right, in the morning at 5 a.m., right? At 5 a.m., if you want me to conduct a session for last minute revision for your full chemistry within 1.5 hours, then let me know in the comment section. Okay? Yes. Okay then, bye-bye. Take care. See you all students in the next session. Till then, all the best. Take care and keep studying. This is Diksha Kaushal signing off.